Hey everybody, this is Mr. Oliver. I'm going to be doing the solution to the AP Physics 1 Unit 2 free response practice problems. This is going to be question 1 first. So let's go ahead and get started. All right, so for this first question, you always want to read the question carefully first so you understand what's going on. So it says a student strikes a block at the bottom of the ramp, giving it an initial speed v0 up the ramp as shown to the right. There is friction between the ramp and the block as it slides a distance x up the ramp and then slides back down. So here's our little diagram. We've got this block. Someone's going to hit it from the bottom and it's going to slide up the ramp. It's then going to go x meters up, stop, and then slide back down. So for the first question, it says on the dots below, which represent the block as it is sliding up the ramp and down the ramp, draw and label the forces exerted on the block. So it goes through a lot of explanation. All it's basically saying is draw a free body diagram for both when the block is going up the ramp and also when it's going back down the ramp. So when it's going up the ramp, our object will have a force of gravity going down. Okay. It will also have a normal force, which is always perpendicular to the incline. So there's our normal force. There's also going to be friction, and if it's moving up the hill, then the friction has to oppose that, and it's going to be going down the hill. So that's whenever it's moving up the hill. Now, in the second scenario, when it's moving down, do the same thing. We start off drawing your arrows from the dot pointed away, so you still have force of gravity going down. The normal force hasn't changed, it's still going perpendicular to the ramp. But this time, as it's slowing down or going down the hill, the friction has to oppose that motion. So this time the friction flips direction and goes the other way. All right, so for that's question A, and it's only worth 2 points. All right, one for each correctly drawn diagram. And question B says the block takes time t up to slide up the distance up the ramp at distance x. So it's saying that the time it takes to go from here up the hill takes t up seconds. Then the block takes t down to slide from the top part of the ramp back down the hill, t down, where it has a speed v final. Is t down, the time it takes to go down, greater than, equal to, or less than t up? So before we go and start writing the question down, let's just kind of analyze what's happening in both the up condition and the down condition. So in the up condition, when it's moving up the hill, you need to think about it like this. It's moving in this direction, up the hill. Well, if you look at the free body diagram, there is a component of gravity, a downhill component of gravity. This guy right here, it's moving straight down the hill, down the incline, and that's FG sine theta. Remember, that's the opposite to our angle theta right here. And so in the up case, you have two forces pointing down the ramp. Let's say you got forces pointing down the hill. You have friction plus FG sine theta, two forces that oppose its motion. All right. However, in the other case, when it's moving down the hill, you have that same force of gravity component down the hill, Fg sine theta, that's pointing down the hill. You have Fg sine theta. However, you also have a frictional force pointing up the hill. Now, these values aren't equal because obviously it's sliding down the hill, but the point I want to make is because they have two forces opposing your motion going up, it's almost like you're putting the brakes on twice. You've got gravity pulling you down as well as the friction kind of holding you down. So that means that the time to stop here the time to stop is going to be short. It's the same thing as if you're driving your car and you drive up the hill and you lay on the brakes. Well, your brakes slow you down because there's friction, but also the hill slows you down because you're going up the hill. And so you'll stop a lot quicker in this scenario. But over here, the time to stop will take longer. And the reason why is because, the friction is going to slow you down, but you have force of gravity kind of wanting to speed you up. And so in that second scenario, when you're trying to go down the hill, the time to stop is going to be long. So what you can conclude is that the time to go down the hill must be greater than the time to go up the hill. All right. And so when you're writing your paragraph length response, what you want to do is you want to make sure you kind of, I would suggest sometimes is just sketch out a list of things that you know. You know this, okay, so that's kind of one of the first things to do. But you also know that the net force when you're going uphill, kind of the net force when you're moving uphill, net force moving uphill is greater than the net force when you're moving downhill. Okay, so that's one thing that you know. And you also know that because net force has to do with acceleration, because F equals ma, then you have to conclude that the acceleration when you're moving up is greater than the acceleration when you're moving down. And then that kind of leads into something else, because acceleration has to do with velocity, because there's a kinematic relationship between it. Remember this, v is equal to v naught plus at. The more acceleration you have, the more velocity you have. And so what you could do is say, well, when you're moving up, the velocity is going to be related to this acceleration. So specifically, it's not the velocity, it's the change in velocity is greater than the change in velocity when you're moving down. Okay, and then you could make one more comment that, well, velocity is related to time, because once again, kinematics and all that motion stuff. And so your time to go downhill must be greater than the time to go uphill, because you're faster in one case than the other. All right, and so when they work out the points for this, as long as you're writing a statement that kind of addresses these facts in a clear, logical, consistent argument, then you'll get a fair number of points. So here's what I wrote, and I know you probably can't read this, but I wrote, in the going up case, both friction and a downhill component of gravity, mg sine theta, act in the same direction. This causes the deceleration of the block to have both frictional and gravitational effects, contributing to slow down the block as it moves up the ramp. In the going down case, friction points up the ramp, but the downhill component of gravity still points down the ramp. This causes the deceleration to come from a difference in these values. So therefore, the deceleration will be less than before. This means that the time to go up the ramp is less than the time to go down the ramp. All right. Now, that's kind of using it, kind of explaining it in words, but if you had the time, you could just make up numbers for the initial velocity, the mass of the block, the coefficient of friction, the angle of the ramp, and you could work out the math and show that it has to be true. And so you'd be using some kinematics, a little bit of force analysis, and that's a process that typically on an AP Physics 1 test they won't expect you to do, but it is support for your answer. So if you had the space and the time and you wanted to include those calculations, you could say, to verify this statement, a set of kinematic equations or a set of calculations are on another page, and that is support for it. So that's That's the solution for the first one. And in the second video, you'll see I'll go over the solution for question number 2. All right, thanks.